Hi guys, so welcome to the binary logic lecture. This is the first in a series of many videos that's going to teach you about binary logic. So the basics of binary logic is that there's actually two unique digits in binary. This, if you don't know, is 0 and this is 1. And there's only two unique digits. And if we compare that to our human counting system, we have 10 unique digits. We got 0, 1, 2, 3, 4, 5, 6, all the way up to 9, right? So there's 10 unique digits because there's a 0, there's a 1, there's a 2, you get the idea, all the way up to 9. That's 10 unique numbers. And after we run out of those digits, when we go up to 10, we're just recycling our 1 and our 0. The 1 and 0 are unique symbols, which we taken from the human counting system, but the 10 was recycled. So this is not symbol. Ooh, wow, I wrote that terribly. I hope y'all could read that. So in binary, there's only two unique digits, 0 and 1, and we refer to this as base 2. So in binary, if there's two unique digits, then it's base 2. So in our human counting system, where there's 10 unique digits, 0 all the way up to 9, this is base 10. So now that you guys understand the idea of that, we're going to move on to how binary, or how computers communicate with binary. So this is a computer, right? Now, some of you may be wondering, how does a computer talk with zeros and ones? Like if I talk to something with zeros and ones, it's not going to do anything. Well, actually, zeros and ones are abstractions, meaning that they just represent something else. So the 0 represents no electricity, while the 1 represents electricity. So, to show you what I mean, we're going to start with a basic example. Now, electricity, hope this is a good symbol, it causes things to move. So for example, let's say that I have two switches, this, and I want to connect it to this. Now, the basic idea is that if I send electricity over here, it's going to cause magnetism, which is going to attract here and here. And this is just basic magnetism. Electricity causes magnetism. And if you guys are confused about this, don't worry too much. We're just going to be focusing on the math of it all. But electricity causes movement. And why am I telling you guys all this? Well, the point for binary logic is that a 0 means no movement, while a 1 equals movement. So one more thing I want to cover before we end this video is universal in nature, and this applies to all bases. And now, this universal truth, this universal axiom that I'm about to tell you guys, is a pretty simple fact. So let's take the number 129. And the universal fact is that this is going to be equal to the following string. So this is base 10 right here. So we're going to take this 10, we're going to bring it down here, and we're going to start at 10 to the 0. Oops. 10 to the 0. Now, what are we going to do with this 10 to the 0? Now we're going to multiply it by the first digit in the series. So the first digit here is 9. So we're going to take 10 to the 0 multiplied by 9. And this time, we're going to add to the next digit. So we're going to take this digit 2, and we're going to raise this exponent by 1. So this is going to now be 10 to the first power multiplied by 2. and we're going to do the same thing again. We're going to raise this number right here to a 1, and we're going to raise this exponent from a 1 to a 2. So this time, we're going to multiply to, what do you think? 10 squared multiplied, this should have been plus, I'm sorry, 1. So this is a universal truth. This holds up to every single base, no ifs, ands, or buts. And to prove to you that this is true, we're going to recalculate. So 9 times 10 to the 0, 10 to the 0 is 1. So we're just going to get 9 plus 2 times 10 to the first power, that's just going to be 10. 2 times 10 is 20. And then 10 to the second power is 100, and 1 times 100 is 100. So if we add all these numbers, we get 129. And I'm going to show this to you again so you guys can get a full grasp of what I'm saying. We're going to take the number, let's say 298. Now, what we did last time, base 10, we're going to take this number, this 10 here, and we're going to start at 10 to the 0 power. And we're also going to take the first digit in the sequence, which is an 8. So 8 times 10 to the 0 plus 10 to the 1 this time, because we're going to be adding 1. 10 to the 1 multiplied by the next digit in the sequence times 9 plus, we're going to take the next digit in the sequence, which is a 2, and we're going to raise this base 1. So now it's going to be 10 squared times the 2 here. And this, we're going to prove that this is a correct statement by just going back. So 8 multiplied by 10 to the 0, that's just 1. You're going to get 8 plus 9 times 10 to the first, that's just going to be 90, because 10 times 9 is 90, plus 2 times 10 squared. This is just 100. So 2 times 100 is 200. And if we add these up, we're going to get 298. Now we're going to work through one more example, alright? Give yourself a big pat on the back. You're doing very good. But we're going to convert this time a 4-digit, 8,946. And we're going to follow the same system that we followed last time. If you think you know how to do this, then pause the video. So, let's get started. 10 to the 0th power this time, because we always start at the base 10. If this is base 10, then we're going to start at 10 to the 0, multiplied by the first digit, which is 6. Then we're going to go down the line to 4, and we're going to increment this by 1. So plus 10 to the first power this time, multiplied by 4. We're going to go down the line, plus 10 squared, incremented, times 9, plus 10, and guess which one? Third, incremented, times 8. And we're going to add all these numbers up and prove to you that's true. So 6 times 10 to the 0, 6 plus 4 times 10 to the first, 40, plus 9 times 10 to the second, 900, plus 8 times 10 to the third, 8,000. And we add all these numbers up. Sorry for the sloppy handwriting, by the way. 8,946. And you might be wondering, why is this so important? Why is this such a useful tool? Well, it's because we could convert from any bases. So our final example for this video is going to be converting from a binary base or base 2 of 1011. This is in base 2. And we're going to convert this into numbers that we could read. Now, this time, since we're converting from base 2, we're going to be using 2 instead of the 10. So we're going to start at 2 to the 0. And we're going to go down the line. So we're going to start this 1 right here. We're going to multiply 1 times 2 to the 0. Plus, we're going to go down the line again to another 1. Because remember, there's only 2 digits. So we're going to increment this 2 to the 1 multiplied by 1. Go down the line, 0, plus, now we're going to increment this again, 2 squared times 0. Then we're going to go down the line, 0 to the 1, because we're going down the line, plus 2 to the third times 1. And now, we're going to convert this into a human readable number. So we're going to take 2 to the 0, and we know that anything to the 0 power is just 1. So it's going to be 1 times 1, 1, plus 1 times 2 to the first power, that's just going to be 2. And then 0 times 2 to the second power, we know that anything times 0 is just 0, plus 1 times 2 to the third power, which is 8. So 8 plus 0 plus 2 plus 1 is going to be 11. So now we know how to convert from binary or computer readable numbers to human readable numbers. And I'm going to give you one problem to take home and try to solve for the day. So I want you guys to try to convert 1, 1, 1, 0 into a human readable number from base 2. And I want this in base 10. Now, when you're done with this, open up the comments. You're going to see an explanation and all the things that you need to know and how I got this. But this is your little challenge for the day. But thank you for watching my video. I hope you know a little more about binary than you did yesterday. Have a great day.